Yeah, so we start with Eran, who's going to give us a bit on drift in Kubernetes specs.
Hi, everyone. Thank you for joining my session. And this session will be about Kubernetes drift and infrastructure drift in general. I will quickly describe the challenge with drift and also share a few ways to mitigate them and also to create some awareness around this topic. My name is Eran Bibi. I'm the co-founder and chief product officer at Firefly. And before that, I was the head of DevOps and SaaS platform at Aqua Security. And in general, I'm doing a DevOps for more than a decade. I really like the community and also all of the ecosystem involved in cloud engineering and infrastructure as code. And before I will deep dive into the drift topic, I think that every good Kubernetes story can start with the way that we have to provision a new cluster. And as you can see here, basically there is plenty of ways to create a new cluster. You can do it the hard way. This is a very difficult way, but highly recommended for the guys that would like to do a CKA certificate. But there are also some automation tools like the kubeadm command line that is going to help you to create a cluster in a more easy way. And then there is some more traditional ways like using the cloud console, for example, going into the AWS console and create an EKS cluster, and other utilities like COPS and EKS-ETL to do it command line style. But in this discussion, I'm going to be more specific around Terraform, which is an infrastructure as code framework. And with infrastructure as code, there is a few popular tools. Terraform is one of them, but there is also Pulumi, CDK, and this is a very good trend of the way to manage infrastructure in a modern way. And the reason for that, for the guys that doesn't familiar well with infrastructure as code, is basically allowing to developers and cloud engineers to describe the infrastructure like they are describing code, and also enjoying all of the pipeline of code verification and code reviews. And of course, with additional tooling in the ecosystem, you can also do in a shift left for a testing, like a security test, and also cost predictability. And this is a very recommended way to manage infrastructure nowadays. Saying that, there is few challenges with infrastructure as code. One of them is infrastructure drift, and now I'm going to explain more about this problem. So when Firefly basically scanned the customer for infrastructure drift, we found out there is something like 90% of the current deployment already have drift between them. 50% of those drift were even unnoticed, meaning the cloud owner did not aware that there is a drift between the infrastructure and the cloud deployment. But saying that, if we are talking about what is the impact, so every drift is something that eventually need to be mitigated. It's either to align the configuration in the cloud or to align the infrastructure as code to be aligned with the new parameter in the cloud. And 20% of those drift can be something that can impact the reliability of the platform or even get in some security issues. So what is infrastructure drift? So it's very simple. When you are describing something as code in your source control, you're basically expecting that the same configuration will be running on the cloud. But drift is when there is a deviation between what you think there is in the cloud and the actual state of the cloud. And I can give you one illustration to explain it. So what you can see here is basically an HCL Terraform module that is describing a piece of infrastructure with a very simple set of properties. But when I'm looking on the real actual state of that configuration, as you can see, it's basically drifted away. So the actual state and the desired state is not equal, and this is basically drift. But again, I'm just kidding here, and this is just an illustration. So let's see like a real life example of an actual drift. So what I have here is a Terraform block that is basically describing an IAM policy. This specific IAM policy is for listing DNS records. So the name that I gave to that policy is list route 53 resources, and you can see the action is basically list resources, record sets, and also list hosted zone. So every user that have this policy attached to him supposed to have the capability to see all of the DNS records in the cloud. So once I deploy that configuration, this is the initial state of the configuration. But in most of the cases, when the times go by, when you go to the console and basically get the status of the configuration from the cloud vendor, you can see that there is a small deviation. So this deviation is basically another set of permission that is eventually giving a full access to that role. So this is a typical example of a drift. You configure something as a read-only, but when the times go by, someone or some third party, and I will elaborate on that later on, change the configuration and basically create those drift and elevate the permission of that specific policy. Let's see another example of a Kubernetes drift. So what you can see here is a Kubernetes role, and this Kubernetes role, I will call it a pod reader, basically have a get, list, and watch capabilities. But when I'm going to the cluster itself and do kubectl describe role, I will see that in addition to the get, list, watch, I have also patch, create, update, and delete, meaning I was describing something as a read-only, but the actual state was drifted, and now it's an elevated permission. This is also something that we tend to see in a lot of our customers. So what causing those drifts? The first one is manual change. If the organization is large enough and there is a lot of engineers having permission to touch the cloud, we tend to see that in some of the cases, it's easier to create a manual change to configuration rather to go through the infrastructure as code pipeline and doing all of the cycles and the validation that is needed. It's also happened in some emergencies. So if you're getting a call in at 2 a.m. about some incident and you need to change the configuration, it's easier to do that manually. I'm not saying it's preferred to do it, but it's easier to do it and mitigate it very easy through the cloud console or through the API and basically create a drift after that. Another reason for drift is basically the change between the environment. So what we are seeing basically is when you are deploying an infrastructure as code on a staging environment and then using the same template to the production environment, in some of the cases, there is a developer-driven changes on those staging environment, and it's creating a drift between the way that the staging is look like and the way that the production is look like. And this is also one of the main reasons for a drift. Another item is a third-party applications. A third-party application that create a drift in a few examples can be a CSPM, like a security application that have the permission to alter the cloud. It can be a security group or other resources like an IAM, but eventually it's a conflict between the infrastructure as code and the actual footprint in the cloud that caused by a third-party application. Another example is a cloud optimization tools. if you have some tooling that is able to scale up and scale down resources in the cloud, in most of the cases is going to be a conflict between the infrastructure as code and this tool. So this tool will create drifts. Another reason is because the cloud is also evolving, and also the tool set like Terraform is evolving. In some cases, the version that you have for the tool is not aligned with the cloud API specification. That this is also one reason for drift. We know about a recent change that Terraform did in an S3 resource, and this may cause a lot of troubles for people that use in infrastructure as code to describe their S3 buckets. They need to align the specification in order to avoid conflicts and drifts. And the last reason is unmanaged assets. And unmanaged assets is basically those assets that already exist on your cloud before you use the infrastructure as code. So if you're using infrastructure as code for like a greenfield kind of project, it's okay. You can assume that every resource in the cloud will be described as code. But in reality, the cloud already have a bunch of resources in place, and those are not codified. If I will conclude all of those resources and drift as an old topic, we can surely say that drift can cause real issues in the cloud. So it's either a security issues, a cost-related issues, and also something that can cause a real reliability risk to your cloud. Going back to Kubernetes as an example for a drift, basically there is two verticals that you need to be watched for when you're talking about managing Kubernetes cluster. So you have the one vertical of having the infrastructure of Kubernetes, like the management console, the VPCs, the security group, the storage, everything that related to the infrastructure that's running on the cloud. In most of the case you will use either CDK, Terraform, or Pulumi to provision them. But in Kubernetes, you also have the configuration inside Kubernetes, the manifest, the role-based access control, the services, the ingress, the stuff that is either described in Elm or other package management. And you also have a drift in those configuration as well. So on Kubernetes, you need to watch for a drift detection for both angles. And to be more precise about what you can do in order to handle drift, there is few alternatives. So first of all, you need to make sure you have the awareness about the situation, and you need to distinguish between a risky drift and something that you can leave. For example, if you have a drift in a tag, for example, you deploy resource with certain tags, but then you have a third-party application that enriching and adding more tags. So it's causing a drift, but it might not be that problematic for you, and it's not going to cause any issue. So just need to do that classification between the type of drifts. The other one is to create some alerting to understand when there is a drift, and basically know about the drift when it's happened, and not discover that drift later on in the process. So you need to implement some drift detection tooling in your CI.
Hi, we are Eficode, and we organize the DevOps Conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at eficode.com. The links are in the description. And have a great time with the DevOps Conference talks.
And of course, once you have that alerting in place, you need to make sure you have the right playbook to mitigate the drift, because mitigation of drift can be either aligning the infrastructure as code to be set to the new version that you have on the cloud, or to override the new change that be done on the cloud with the stuff that you already described in your code. So this is basically a simple recommendation to implement a drift detection that can be done without any extra cost. It's not a perfect solution, but it's good enough, and we see a lot of cloud owners using this methodology. So basically, it's to run in a Terraform a plan in a cron job. So in case Terraform detect a drift between the desired state and the actual state, you will know in real time. You can also add a Slack message or a webhook message, and this can be done very easily with some basic scripting while detecting the exit code of the Terraform plan command. You can run it on your CI/CD or in some cron job, but in any case, this is something that you can implement even today without having a lot of investment on this specific detection. Another approach is to use GitOps. So GitOps, in a nutshell, is basically declaring the Git repository as the source of truth of the deployment, and having a GitOps operator running in your Kubernetes cluster that is basically reconciling the state of the cluster with what you have in Git. And GitOps is a very good way to mitigate drifts, because even if you have somebody with a permission to do a change to your Kubernetes cluster, then the GitOps operator will always reconcile the state with what you have in Git. So this is a very good approach to embrace on Kubernetes. But if you have a drift situation in a broader scope, you might need to consider a different kind of approach. So some takeaways, stuff that you can take with you and even implement today. So there is a very nice project, an open source like DriftCTL and kubediff that you can implement in a cron job or CI/CD job kind of way in order to get more visible and alerting about drift when it's happened. If you have a Kubernetes cluster, you might consider to switch to a GitOps methodology, and then only the stuff that you have on your Git repository will be the source of truth, and the operator will reconcile it even if somebody created drift. Argo CD and Flux are a great example of tooling that you can implement in order to enjoy GitOps. And of course, one of the advantages of this presentation is just to create an awareness about drifts, and maybe you can have some more limitation about the cloud and the stuff that can introduce to the cloud manually, and this is also a way to avoid unnecessary drifts. Thank you very much.
Thank you.
Thank you.
I was wondering, Eran, how do you handle drift in cases of multiple infrastructure as code projects kind of co-owning resources, or at least like collaborating? How can you resolve situations where that happens? So
it's a great question. So I think one of the main challenges that we see right now is that fragmentation of tooling. So, you have a different kind of tools to different kind of workloads. And we also see among our customers that even if one team decided to use Terraform, in the same organization, we see that a different team choose Pulumi for a certain kind of workload. So because it's like each team or each engineering group decide their own stack, we see a lot of conflicts around that. So specifically in Firefly, we're able to detect like if there is an asset that is managed by multiple stacks. So of course, we are offering our solution as the way to get those visibility for that. But I agree, Adrian, it's a great, it's one of the major challenges that we have right now is, multi-clouds, multi-accounts, and multi-infrastructure as code tool, and it can be a very messy situation.
Mm. So does that also solve? Oh, actually, we have a question, so let's go with that before I ask all my questions. Zenith asks, does Terraform provide cron job logs, same as your example, AWS, to detect the drift by comparing the states?
So Terraform Cloud, basically, it's like that. When you're using Terraform Apply, it can give you a drift detection. Terraform is basically comparing the state file and the actual running configuration and give you alert in case there is a deviation. What I suggest in that talk is just to use that capability in a cron job kind of way, because Terraform plan is a command. If you just wrap this command in a shell script, or even in a, assuming you use in a Jenkins job that run periodically, you basically can get a very simple but very efficient drift detection capability that is triggering, giving you the alert, and you will not be surprised the next time that you're doing a Terraform plan.
I see.
If you have more questions, go.
Postman vote. Yes. Cool. If you've already saying, but cool. About that drift detection with Terraform, what's the best practice to ignore changes, automatically added tags? Because there will always be a change detected. Is this a pattern matching situation then? Yeah.
I'm not sure if I got the question right, but
so
again, I will give you my take on drifts. Drift can be something not significant. Again, tags, it's a very good example of something that was changing your cloud and it was not like the desired state, but the impact is not that severe, right?
Mm-hmm.
We see that people, describing tags in their infrastructure code, which is amazing. This do that, but they have another kind of processes in place that automatically tags resources on the cloud. So this is creating a drift, right? In this case, I will basically ignore this drift because I say, okay, it's not aligned, but it's not something that I need to handle and mitigate.
Okay, so then is there tooling available to kind of suppress those warnings or those kind of drift detection?
Yes, of course. You can basically ignore some of the properties and having only the stuff that is really important alerting you, and the stuff that you consider as less than an issue, just ignore them. Yeah.
Cool. Suppressing the noise. Cool.
Yeah, of course. There is I'm not sure if I got it right, but there is like a ignore file, .ignore, Terraform ignore file that you can basically say to Terraform, just ignore that specific property and go on like there is no drift.
Oh, interesting. Cool. Ismail's asking if there are drift detection tools for alternatives, or if you're not using Terraform. So, for example, like if you use CloudFormation, how would you detect drift?
So CloudFormation have a built-in drift detection capability. This is one of the advantages of using CloudFormation. But it becomes very challenging when you have those, multiple kind of set of toolings in place. So Terraform, you can fetch that kind of process that I just described. CloudFormation have a built-in drift detection in place. I'm not sure how it's good in the way of alerting, but the capability is in place for sure. We have some customers that using CDK and CloudFormation and having those drift detection in place. Also, if you're using Pulumi Cloud, there is a drift detection for Pulumi Cloud.
Okay. Cool. Yes, let's go to the next question. Marco is asking, what about tools like driftctl for Terraform? So driftctl is a new name to me, so can you briefly explain what it is?
Yes, driftctl is an open source project. They're recently acquired by Snyk, which having some security tooling for developers. And it's have a very nice drift detection capability, and you can also use that as an alternative for Terraform plan kind of process.
Cool. Yeah. So one of the issues I'm noticing with like Drift is not that much that resources change, but that we have kind of left behind resources. So this happens when we would create a preview stack, we deploy it, and then while it gets destroyed, we forget resources. Is there tooling which kind of the moment that your IAC loses track to pick up on those and safely but efficiently kind of clean up after ourselves?
So again, my take here is to use Firefly, because Firefly is doing exactly that kind of discovery of unmanaged assets. But what you're describing is something that happened to a lot of the users that we are seeing. It's not like the Terraform destroyed, given left behind. Also, think about it. When you have a Kubernetes cluster, Kubernetes cluster tend to create more resources in the cloud. For example, if you have Ingress, it's creating a load balancers. You have a PVC, is creating a storage device, right? We see a lot of those clutters in the cloud because the API calls to destroy them sometimes not that successful. So you can have like a Kubernetes cluster, you enjoy it, you destroy it, but you're left with a bunch of costly load balancer and EBS volume in your cloud. And again, this is just the beginning. We see a lot of mess on those kind of situation of leftovers.
Cool. I also saw someone in the chat mentioning AWS Nuke, which I guess is very effective at times.
Well, I'm not personally not familiar with that, but I will take a look on that right after the talk.
Cool. Another question from Zena. What do you recommend for drift detection for GKE made by Terraform? GKE.
GKE for Google, I guess.
Yes.
Again, if it's made by Terraform, the very easy and basic way to get awareness about drifts is just to run Terraform apply in some sort of scheduling. Again, it's not cover all of the drift scenarios. Maybe drift CTL is better in that specific case, but it's either that or that can give a very good solution without a lot of effort.
Can you tell us a bit more about Firefly, because you've mentioned that it solves like a lot of issues? So just like what's like the elevator pitch?
We are a cloud asset management that scan your cloud and also scan your infrastructure as code and giving you that visibility about what portion of your cloud is described as code, what is unmanaged, and what is drifted. And we also giving you the capability to increase the coverage, meaning if you see some of the environment or assets that you did not codify, Firefly will create the code for you in Terraform, Pulumi, CDK, whatever kind of tooling. So drift is one of the stuff that we are handling, but it's more about how to get opinionated cloud and all that is also aligned with the stuff that you desired, without any surprises like cloud clutter and other stuff that we see. That it's really challenging, in a large scale.
That code generation actually strikes with me, because sometimes when I'm developing, I intentionally create drift and then I ask my Pulumi to kind of figure out like what's the div, just because it's easier to figure out like some very obscure types, specifically the Azure native package, which is directly against the Azure API, and the types are impossible to get right. And then you just ask it, effect Pulumi, like, can you please tell me how do I do this? So that sounds actually quite even useful in production, but that might be a bit of a hack. But yeah.
So this is amazing use case, Adrian, that is working for us. So what Firefly doing in that case is basically automatically opening a pull request in the place where you are saving that drifted property and giving you that entire automation in order for you to mitigate those kind of drifts.
That sounds neat. So how does that work actually when you have multiple environments? Then it figures out the drift happened in a certain environment, and then it creates a PR against the config or against the code?
Okay, so it's basically for you to decide. So Firefly is not doing a change on your cloud. So if you would like to fix drift, it will be automatically creating a pull request to align your infrastructure as code to be set with the cloud. I'll give you more precise examples. So if you have some tooling that is scaling stuff in your cloud, and as I mentioned in my talk, they are basically conflicting with the way that you described it, then one of the way is changing the configuration in your Git. So Firefly doing the entire kind of flow automatically for you. So assuming that the change was good, you have the infrastructure as code aligned. If it was unintentionally or something that is not like the desire, Firefly will basically notify you, and then you need to run the Terraform Pulumi apply again to overrun the configuration on the cloud.
I see, I see. Okay, I guess we can do one more question and from Socrates. It's about specifically like tooling for creating these pull requests. So you already mentioned that Firefly does this, but are there other projects or tools available which kind of are mostly there to create these PRs for you?
Not that I know of stuff that having the capability to identify exactly in your Git. It might be have something I'm not familiar. I'm very well familiar with drift detection utilities like driftctl, kubediff, but not the stuff that giving you the entire cycle of mitigating and creating pull requests automatically.
Cool, cool.
Wonderful. I think I'll have to stop you both in the interest of time right now. We have our next speaker waiting. Eran, I would recommend all the audience to, if you have more questions or would like to further continue the discussions, please get to Eran in social media. Yeah, thank you having you at the conference. Have a great day.
Thank you. Bye, guys.